Everyone always starts with thanking the organiser for inviting me. So I'd like to thank the organiser, but also the community for having me here, because I'm sort of a bit of an outsider. And I really enjoyed the whole event. I particularly enjoyed also yesterday's, coming from the publishing industry, seeing where it all began in Gutenberg's printing press. So that was great. And I'm going to, as the title says, talk a little bit about what goes on inside nature physics, because that's where I work, but really I guess what I'm going to talk about is broadly what goes on inside every nature journal. And people normally have this as the picture of what goes on inside nature physics, black box, like potentially a little bit random, arbitrary decision-making process. And what I'd like to convince you that it's not random and arbitrary, is that there is a framework and we stick to that. And of course, there are subjective components of this framework, which obviously I'll try and describe a bit, but it's not random. And the plan of the talk is as follows. Normally, this talk I tend to give in about 45 minutes, so I might have to rush through some sections. But I think the most important part is the first three. So, give a bit of background of nature, sort of the journal and the company that we belong to. The publishing landscape of physics, I think, is helpful to give everyone a bit of an idea of the context, because the point of, one of the things I learned when I moved away from research is that physics looks very different when you see lots of papers in the editor. And then I'll describe the editorial process at Nature Journal, which is sort of really the essence of what we do. And then towards the end, if there's time, if you're interested, I can sort of spend a bit of time discussing peer review, a little bit of its history, and sort of recent developments. Essentially, publishing is undergoing rapid change at the moment, and the current status quo is going to change. So Nature, of course, is very old by company standards, very old sort of institution. The first issue of Nature was published in 1869, and actually kind of started as a sort of an offshoot of the gentlemanly kind of Royal Society, sort of men of leisure that had time to do science needed somewhere to publish their work, and there were a number of sort of venues for this, and Nature was one of them. I've heard, I'm not quite sure if this is true, but I've heard that it took them 10 years to start making a profit. So it was, to begin with, done just because people thought it was interesting and there was rich enough people to support it. But the mission statement has been the same pretty much from the very beginning, and I'll quote it here in full, which is to place before the general public the result of scientific discovery and to help scientists to learn about advances in all branches of natural knowledge. So it's a twofold mission, and I think that's key to bear that in mind when you compare us, say, to other journals. The idea is, yes, we'd like scientists to be able to communicate with each other, but we'd also like the wider public to be able to appreciate and somehow celebrate these achievements. Historically, I think people tend to associate nature more with biological sciences. That's really changed over the past 10 years, but we do publish across all the natural sciences. And I'll just confront this head on, we are a privately owned company, we aim to turn a profit. And I say we're owned by Macmillan. The reality is that now we're owned by a much bigger company. We're actually journal owned at the end of the day. So there you go. Okay, so there's the first issue of Nature. The idea is to try and publish the most important advances in science, and there's this sort of idea that it's at least in theory or in principle, you want to publish something which interests everyone, that people can sort of objectively go, wow, that's quite a big discovery. So, I'm talking, think about exoplanets or a dinosaur the size of a house, and that's something which a non-expert or a scientist from another community can sort of appreciate that's an unusually important discovery or significant or that kind of level of discovery. However, and this is how Nature looks today. One of the things that became sort of clear pretty much straight after the explosion of the internet, when it became cheaper to launch journals, was that Nature was rejecting a hell of a lot of fantastic papers, and it was receiving lots of papers that were clearly very high technical quality, that were clearly very interesting to large communities, maybe not all of the natural sciences. And so essentially there was this space for what we call research journals. Nature Physics is an example, is the one that I work for. But you can also, you can do the same argument for nature chemistry, nature materials, so material scientists. So you can see where this is going. A whole stable of journals was launched that focuses on specific communities. And actually, the brief of these journals is quite broad in its own right. So if you think about it, nature materials is an extremely broad spectrum of research. Nature physics, well, it's huge. And so the idea is here, okay, we're not trying to necessarily convince biologists this is amazing work, but the idea is maybe people in magnetism might have made a discovery which somebody working in biological physics would consider noteworthy. So that's the space where we sit. Okay. There's a lot of papers published in physics, and physics is not even one of the biggest areas in science. This is 2012. Numbers have probably grown dramatically since then, but I just want to, this is just to give you some sort of idea of the size of the market. So, okay, we're here. Nature Physics publishes a very small amount of papers, basically 130 papers a year, order of magnitude. And if this is the total number of papers being published in over the course of the year across all of physics, then, well, I would put to you that no single human being would either want to or can read all of this stuff. And I guess, that's, this is something which people often forget a bit, that there really is an enormous appetite to publish papers. And these papers end up in a range of different venues, and these venues can be, say, where is PRL? There it is. PRL is publishers actually, I think that number's come down now to sort of more like 3,500, but it's just these are the numbers basically. It's just like, and Nature Physics is publishing a tiny fraction of that. Of course, there are other nature journals as well. So there's Nature Nanotechnology, Nature Materials. So I guess we're a bit bigger than what we say we are. But I just wanted to really drive home that we publish a very small fraction of the papers that are out there, and we look for the best.
Are these only physics papers published in these journals, or is it?
Well, no. Okay, so actually, you're right. Science and nature, I think that's all of them. I should have divided out, or should subtracted out the biology papers. And so then you have the ideas of scope, because people try to target specific communities. As authors, people go, well, my result is a bit fundamental. I'd like to try PRL, because that's where I think my main sort of audience is, or my peers are going to be reading that. Maybe you're more applied, so you'll go to the Nature Nanotechnology. The big change since 2012, which I think you will notice by now, is that there's been this, through the fact that open access mandates from funders have started taking hold. There's been a market for so-called mega journals, so these journals that don't have essentially any limit to what they can publish in terms of length or number of papers. And this includes journals like Nature Communications and Scientific Reports, but also Physical Review X is open access. They actually take a different approach. They are very selective, but they could in principle publish as much as they wanted. But what I'm trying to say here is that if these numbers from 2012 look big, they've got bigger now, and I think it's fair to say that all the publishing houses, all the scientific societies that publish papers are basically now viewing publishing as a fight for market share. That's actually a change in the dynamics of the industry. I can discuss on that later if you're interested. I think this is a question which I think I'd like to address, because many people sort of regularly bring this up, and if you follow blogs on the internet, this always comes up in a lot of communities. The internet has changed things, and with Google you can pretty much find anything like that. And in physics there's this great thing called archive, so you could even ask what's the point of journals. I mean, journals kind of, you submit to a journal, we filter and we publish, and you could turn that around and say, well, just publish and then filter later. You could have some crowdsourcing way of doing it, or like buttons. And technology also exists to make that happen. I'm not ruling out that this might not take hold one day, or it might even be sooner than what I think it is. But what I'll put to you is that I think it is still important to reach a right audience. As authors, you want to make sure that you either reach as many people as you can, or you target the people that matter to you. And the other thing which I think is slightly undervalued is that journals help create a narrative for the field. So, you know, everyone remembers, I don't know, a paper that they worked a lot on as you know, that they studied as a PhD student that happened in PRL, and that inspired their work to do the next work that they also submitted to PRL and maybe published. So there are these flurries of sort of research that basically occur because there's a steady editorial hand behind the journals that publish them, and that does actually have an influence, in my opinion. I certainly think that the nature journals and nature physics, we really feel that we shape the fields that we and of course it's a two-way street. I mean, if we get it wrong, we might, you know, publish a paper that causes more trouble than it's worth. Maybe it's like it's a scandalous paper that, you know, contains erroneous physics. Well, that's bad for us. It's in our interest not to do that. So we really have an interest in making sure we publish the stuff that maintains our reputation. So the sort of the system at nature is basically like this big pyramid, and there is this kind of, at the very top of the pyramid sits nature itself. I always call it nature, just to make sure no one kind of misunderstands me. And this journal is in terms of just the statistics bear this out, is the most selective, and the perceived reach and impact of the papers it publishes is the largest. Straight under that are the research journals, of which Nature Physics is one. And then now we have, I don't know, it must be 4 years old now, Nature Communications and Scientific Reports. And you can transfer between all these various journals. It's the author's choice to do that. Like we can just suggest, like, maybe you might want to think about this journal, but we always leave it to the authors to decide where they feel their work is going to be best appreciated. But there's a kind of, I don't know, journal ecosystem, and this is something which again is quite a recent development. It used to be just that journals were very standalone things, and you know, you got rejected by one journal and you went to another one, to a completely different place, and you didn't think too much about it. Now there's a lot more attention to making sure papers stay within a certain Nature publishing group in this case. So what distinguishes Nature from other journals? The first thing, I guess, obviously, is we're very highly selective, and we like this by design. Historically, the reason was because we published stuff in print, we still do, and so we were given page budgets that we had to stick to, and so your submissions are far greater than the capacity of the output that you can produce, and then you have to be selective. But we maintain that still today because basically we think it's still useful to have sort of, you know, to just present the best research every month or every week to our readers. The other thing which I think is important to stress is that we are full-time professional editors. So, you know, most of the journals typically get run by editorial boards that, say, in this case of the APS, so the APS journals, they have a mixed model, but they also have lots of people from the community that, you know, work on the editorial board. We have no other society affiliation, so in principle, at least, our interests are very much aligned with just making sure that we publish the best stuff. Because if we don't do that, then we lose our reputation. And so there's this idea that we are basically completely in it to publish the most interesting physics. Each Nature journal is editorial independent, so I can't access the database or the manuscript tracking system of Nature materials, for example. I am bound to hear about things over lunch or when I cross my colleagues, you know, on the rumor mill, as it were. But broadly speaking, my decisions only apply to Nature Physics. It may well be the Nature materials will take another decision. They have different editorial criteria. And as I say, manuscripts only get passed on at the request of authors if authors think that it's in their interest to do that. And I'll stress this again, the right choice is up to you. So Nature Physics basically consists of two halves. The front half is kind of more of a kind of commentary section, so we'll have editorials, books and arts, occasional obituary, research highlights, the news and views articles, which sort of, I guess, are quite well known. This is more of a kind of, whatever, the stuff that you might read at a coffee table if you're lucky enough to have a copy of Nature Physics in front of you. Then we have what I call the business end, which is the back half, and that's where we publish the research articles, the stuff that people, that we review, that is it's a competitive process to get into. And we also publish the occasional review article. Not so much, but if there's a field that we feel is worth sort of highlighting in greater depth, then I commission a review. And okay, I don't normally do this, but I thought I'd just give you an idea, because I mentioned how there's this concept of that we try to publish stuff which is of interest beyond the specialist community. So I'll just give you a bit of a flavour of the stuff we publish. So here we published a paper last year. This is essentially just a benchtop experiment by some chap in Israel, I think, who essentially created sort of what he claims to have seen Hawking radiation in a laser, or using a laser. And this is something which I think, as an outsider, you go, well, I should probably look into this in more detail. You can't just dismiss it as being uninteresting or interesting only to specialists. Similarly, just to give you a sense of the sort of the scope, we published the occasional paper in sort of fluid dynamics in this case. So here there's some sort of crazy scaling law over many decades that has a similar exponent to do with how animals swim through water. And they have a lot more detailed mechanistic understanding, I should say. It's not just a scaling law. We publish graphene because it would be rude not to, this is, we get a lot of graphene submissions. And this is a paper I quite like because this is sort of, I always say, I've been telling everyone we have this concept of looking for new physics, that we try to, and often our referees seem to also take this to heart and they say, well, yeah, this is great research, but there's no new physics. And that's an argument you can sort of abuse a bit. You can kind of argue that there's no new physics in Schrodinger's equation, and therefore you reject everything. So we need to be a little bit careful. And in this case, this is just one of those papers where they just managed to sort of get anti-hydrogen, keep it somewhere for a quarter of an hour, and that's it. I mean, there's no real sort of new physics as such, but it's a pretty spectacular kind of experiment, I would say. And these are the sort of papers that come very much from left field. It's not something that we necessarily expected would come our way. We didn't really have any connections at CERN for it. But we're very happy to publish it nonetheless. It would be interesting to create adatoms of, well, anti-atoms in the next step. And just to give you an idea of sort of basically we all have our own beats as editors. We kind of divvy up the manuscripts according to broad areas of expertise. So I'm the latest recruit actually. So I joined in about a year ago now. And I say strongly correlated electron systems. My background is in magnetism actually, but I tend to be a jack of all trades. I tend to help out if Julia has too many manuscripts, I might take a few from here. I tend to sort of act as the stopgap solution for depending on the loads that we get. But the various editors, I don't need to go in detail into all of them, all handle sort of fairly broad areas, and the thing that this provides us with is a broad editorial expertise, integrated with the whole journal, and also each individual editor is up to date. We go to conferences, we follow the literature, we know where the traveling wake front is for the various communities that we deal with. We still have to be prepared and open-minded when something comes from a completely unexpected direction, but we do really have our fingers on the pulse, as it were. At least we try to. Actually, sorry, if I couldn't resist to do this because I'll have a little bit of an interview, given my background. I've seen this equation called this Hamiltonian a lot in this conference, and it's kind of interesting because as Hamiltonian I happen to know a bit myself. I actually essentially was interested in quantum magnetism back from the very old neutron scattering literature. So I'll just describe it very briefly. I just want to say it just because it might be interesting to some people here. Essentially, I was interested in these systems like you have these bulk magnets. It's like Jean-Marc was saying the other day. You have bulk magnets where the interlayer coupling is very weak compared to the intralayer coupling is very weak compared to the interlayer coupling. So they effectively are two-dimensional. Fluctuations are dominated two-dimensional, and you're looking at an exchange interaction, an axial anisotropy, and some sort of transverse anisotropy. And I was interested in why it wasn't clear to me in certain continuous spin systems why this term sometimes appeared to be very relevant and sometimes appeared to be completely irrelevant. And the comparison that I did was I dug out these two papers from the early 80s, where you have I just want to draw attention to this fact. I won't go on it very long, but you have basically similar energy scales for these both two systems. The only difference really is that potassium iron fluoride is antiferromagnetic and iridium chromium chloride is ferromagnetic. And what you see, and ignore the rest, ignore what's at the bottom of the table, and essentially they have completely different thermodynamic sort of properties beyond the fact that one's an antiferromagnet and one's a ferromagnet, of course. And the reason for this is essentially to do with the fact that when you can calculate using Holstein-Primakov, you can try and calculate sort of the spin wave spectra and compare them to the experimentally determined curves from a long time ago, and you'll see that in the antiferromagnetic case, it's only D and J or E and J that contribute to these two branches, whereas it's J does not come into it when you're looking at the ferromagnet. So basically, when okay, I'm not explaining this well, I'm not used to talking about physics anymore, but the critical temperature of these systems is reasonably high when you go, so this means that in the critical regime, basically, you're just not worried about these terms. In the case of the ferromagnet, and they essentially have very little influence on what you see, whereas in the antiferromagnetic, they're effectively normal. They become much more strong than you would initially have thought. And I guess the main statement I want to say here is that, in my experience, based on what I saw in the bulk magnetism literature, this E term is likely to be much more strong and influential in antiferromagnets. That's just something that seems to be a general syndrome of behavior. And it's kind of consistent with what Sebastian also presented the day. So I thought that was quite an interesting thing to sort of connect and draw attention to. And this is actually not at all what I focus on in that paper, but I do touch on it in this paper. FYI. Right, back to the editorial process. The thing that we do, which I think is important, and it really does happen, we read all the papers that we receive, and we take notes. We have a system, like a lab work, where we take notes on. We will discuss it with our colleagues, and we want to sort of make sure that we're consistent editorially with the decisions that we take. And broadly speaking, each editor takes about 10 to 12 new submissions a week. I take half that because I also have other responsibilities, but that's to give you an idea about numbers. We try to, not always successfully, but the guidelines, we want to send a decision back within a week, maximum 2. And it's really true, we don't go to impact factor, we look at fundamental or applied advanced understanding. I'll describe this a bit in more detail now, but the point I want to state is, even if we wanted to, I'm not sure how you could predict the impact of the paper. So we just try to look at, we read it and we go, well, there's an advance, and we'll try and sort of follow that up. Okay, so let's say you have a theory of everything, you submit it to us. Basically, in terms of pure statistics, like depending on the field, some fields we're a bit more selective than in others, but on average, like only 30% to sort of 15% of papers get sent out to peer review. The rest we send back a hopefully not rude letter explaining that we're not going to consider it further. And what I always try to do, and what I try to get my colleagues to do, is to essentially explain, try and summarize the paper, what we have understood from the paper. Say, we appreciate that your Monte Carlo simulations looking at the antiferromagnetic fluctuations in the system will be interesting to someone, but we think in light of the flurry of other papers on this subject that it's not quite a broad impact enough for nature physics. And the idea is that I'm trying to convey what I understand from the paper, and if I get it wrong, then you can call me out. You can say, well, hey, you're saying you're summarizing the paper, but you've actually missed the point, and then we can, if that happens, then we'll review it. But we try to give some sort of a reason, which is based on editorial criteria for why we're not considering it. And what we look for when we do send out papers for review is, I like to think of it as, you have the literature, the published literature, and we're looking for clear water between what we're reading and what's in the literature. So this might be a new direction of research, or something is a departure from sort of the general train of direction or the perceived train of direction of the community. As I say, a substantial or arresting advance, a bit like the anti-hydrogen paper I showed you before, a conceptually novel idea that you start thinking about topologically protected states of matter 10 years ago. We're looking for broad interest, so beyond the specialist community. And then this, I confess, in nature physics, I personally struggle with this a bit, practical applicability, for immediate practical applicability, something which you can more or less reasonably say, look, this is going to immediately lead to something useful. My personal view is that if it was really so useful, you wouldn't be telling me about it, you would be patenting it. But we also do try to consider applied physics papers in this light. I just wanted to say that the theory that everything exists. So it's keep on those agreements. And yeah, that's a tongue-in-cheek title. It's about quantum protectorate. It's quite an interesting paper by two very sort of eminent physicists out there. So you can't publish a theory of everything if you've done. I've projected on the basis that it's no advance. Then when we send papers out for review, this is, I would say, the most important part of the referees, of the editor's role is the selection of referees. You know, you want to make sure that your referees have the right technical expertise. So if your paper contains STM, contains DFT simulations, and contains a claim which impacts on, say, the quantum information community, well, you can be pretty sure we'll have an STM expert, a DFT expert, and somebody from that other community. So we're really trying to get all the bases covered. It helps to have a broad overview. So this tends to mean we are more likely to go for more experienced people than not. And also, of course, we like people to be efficient, fair-minded, and we don't sort of, and we always make sure to, like, by doing a quick check on things like Web of Science, that people aren't former collaborators, or that there's no obvious conflict of interest. And we don't know everything, so we don't know whether people have had previous sort of relationships or happen to have a funding application together. We rely on people to be honest in this sense, but in terms of what we see on Web of Science, we really do try to exclude former collaborators. And the most important thing is that your critique is constructive, and you don't have an obvious agenda to just try and sort of, there's no pattern of always going on about the same things and trying to sort of dismiss everything that doesn't fit into that pattern. I mentioned that we tend to go for slightly more experienced referees on average. Having said that, we are always looking for new referees because we do not want to overburden individuals. So as a journal, I realize this is not the case as a company, but as a journal, we have a rule. We basically don't want to ask people to review for us more than twice a year. Now that means that if Nature Materials, Nature Communications, Nature Nano have the same rule, you might in principle be contacted 8 times in a year. But from the point of view of Nature Physics, we try to avoid that. And actually, I dug this out yesterday. I can sort of prove that a bit. So on the y-axis is the number of reviewers. Number of reviewers that we have used, and the number of times that they have reviewed for us. Basically, since 2008, I don't have data from beyond that. Only one person has ever reviewed 10 papers for us, and that's a lot. And that average is less than 2 papers a year. But the vast majority of our referees have reviewed only once for us, and we're always trying to expand our pool of experts. What I'm trying to say here, we're not a club, which is sometimes a criticism that we receive. Okay, you've got your reports back, and it's time to make a decision. And again, this is very Nature style. It's the editor's job to try and collect all the information that comes into the report, read the scientific arguments, and then make an informed decision. Also based on, so if the STM guy is telling you the STM experiment is wrong, you've got to listen to that. If it's the numerical guy saying that he thinks it's brilliant, well, you're still going to have to listen to the STM guy, so we kind of calibrate against expertise as well. And the most important thing is we don't go, well, 2 guys say yes, 1 guy says no, let's go with it. It's kind of, it's all about what scientific arguments are in the reports, and therefore we do rather prefer it when people submit reports with arguments. So just telling me I like it or I don't like it isn't really going to help me make a better decision. Or in fact help the authors improve their manuscript. This is just what I've just said really. The one thing I want to stress is that it's really not unusual for us to find referees that disagree on some sense subjective matters like the degree of the advance, but also on technical matters. The one golden rule that we have is that you never overrule a referee on technical matters. You can overrule, if a referee says, I don't think this is a big deal, but you have strong arguments from another referee or from your own judgment that you think actually you're going to give it the benefit of the doubt, that's okay. That's something the editor has that prerogative to sort of publish the paper. But if somebody tells you this is counter to the laws of physics, then we've got to listen to it, and we can't overrule that. What does occasionally occur, and because you hear people say, well, I know papers that were published when clear red flags were raised, is sometimes what can happen is if there's a clear standoff, we have referee 1, referee 2 saying diametrically opposed things, and the authors saying that referee, you have more than one person suggesting that one referee is missing the point or is focusing on a side issue. At that point, the way around that is we tend to recruit an adjudicator, and that's the only way to do that. We would not be able to just say referee 1 is, we just don't trust him and therefore her, and therefore we're going to overrule it. On technical matters, we have to really take very seriously, and I think this has actually become more important in recent years, where basically the degree of exposure that a Nature paper can give you is quite significant, and therefore if something gets published and there is a clear sort of problem with the paper, essentially, Twitter has a way of creating storms very quickly these days. And the other thing that we try to do is we try to avoid multiple rounds of review. There's this thing we call review fatigue, where basically by the third round, everyone's like, look, for Christ's sake, just stop asking me, do what you want, I'm sick of seeing the paper. So we try to sort of just make a decision as soon as possible of whether we think the paper's going to make it or not. And having said this, if a paper is clearly of interest, but there's lots of work to be still done, we will wait. We're not. There's a bit of an idea that we tend to sort of be very strict on, if a competing paper is published in PRL, that's it, we're gonna drop our interest in the paper we have. That's not really true. I mean, I think it's unfair also on the authors. If we know that the review process takes, works on a timescale of months, then, you can't really hold people on to sort of publication dates which vary by a matter of days or weeks. So we are actually more reasonable than maybe our reputation suggests on this matter. And okay, the decision that you can come up with are basically you can accept the paper, you can suggest that authors revise it, you can tell them, well, you've got a lot of work to do, if you really want to do it, you can come back, but it's on you. And then there's the rejection. So this kind of iterative process. And it's a bit like a renormalization group so fixed point there, fixed point, marginal fixed point goes on forever, and then kind of another fixed point there. Now that's essentially, okay, that's actually pretty much, because I'm up for time, and I think that's all I wanted to really say. If you want in the questions, I can briefly go through a little bit the history of peer review. What I wanted to say was that basically what I described to you, the way that we do peer review at Nature hasn't changed for it was instituted about 30 or 40 years ago, I'm not quite sure exactly when, but it hasn't changed. And what's really changed is the reaction that authors get when they publish a Nature paper. And this is to do with a number of reasons, but I think it's certainly a real phenomenon. And I'll just close on this kind of quote from the former editor of the New England Journal of Medicine, which is essentially, I find my job is full of contradictions. So, my authors, the people that kind of supply me with papers, are also my customers because they're the people that read the papers. So it's kind of a weird dynamic there. And it's also funny that, scientific research, which is one of the most questioning and skeptical of human activities, should be dependent on personal trust. And I really think personal trust is key to the whole peer review system working. And without that, basically, we as a community wouldn't function, and certainly we as a journal would not function. We really depend on that. So I think I'll stop there. Thank you.